Math30-2s, we're going to go over our next chapter, our last chapter of the year, logarithmic functions here. So this is very closely related to exponential functions, the previous chapter we just did, and you'll see very soon why that is. Okay, so the first four things here, they just say, they just want to talk about what is addition and subtraction, how they related to each other. Same thing with multiplication, division, squaring, square roots, cubes and cube roots. And there's other things too, like sine and sine inverse that you might have saw in Math 20 and 10. What all these are, like if you just want to, we could just do one kind of quickly here. It says choose a number. So let's just choose the number here. Let's say 50. Okay. If I add 3,782 to it, and then I subtract 3,782 from it, because that says add and then subtract, what's going to happen is that I'm going to get 50 out. Okay. Same thing down here. So let's say I choose a number 30. I subtract 27, or sorry, I multiply 27. Then I divide by 27. If I did the math on that, what I get out is 30 as well. Or say I do, let's say I take 4, and then I square it, and then I square root it. What I get out is 4. Or same thing if I took like 2 and I cubed it, and then I cube root it, I get 2 out. You know, that whatever I put in, I get out. I put 30 in, I get 30 out. I put 4 in, I get 4 out. I put 2 in, I get 2 out. So these are what we call inverse operations to each other. We can also call them functions as well, if you wanted to say that. What an inverse function is, it kind of undoes the operation. It says down here, it undoes the operation or undoes the function. So more generally would be writing something like this. So I have a function where I input an x, and if I take the inverse of it, and how I denote an inverse of a function is I take a little f, and I put a little -1 like that. So that this denotes inverse. So if you ever see that in the future, this little to the power of -1, and it's not really to the power of -1 because to the power of a -1 is something that's different. It actually means the reciprocal. When you see it in this form where f to the power of -1, f -1 like that, this stands for inverse. So like here, if I put in 50 and I get out 50, so I put in an x of 50, I get out 50. I put in 30, I get out 30. I put in 4, I get out 4. I put in 2, I get out 2. If I put in x, so remember this is like my input, right? What I get out is x, if it's an inverse. So it just undoes the operation. So I put in an x, I get out an x. Seems kind of redundant, but just how it works. So what undoes exponential? So say I have an exponential, y is equal to b to the power of x. So there's my exponential there. What undoes that? So what function could I put around this? Like this here, I put a function around this, so this is all around it. What function could I put around this to get x back out? And that's the reason behind this, is thinking, I can't really solve for this x. I can't rearrange this equation for x. So I got to think of a way to kind of get that back out. So I do the inverse of it. And we had to introduce this new thing called a logarithmic function. So a logarithmic function is the inverse of an exponential function. So what this says is if I take the log of both sides, so it's just like taking, see I have, say I have like a number that's like 4, is the same as 4. If I take the square of both sides, I haven't changed anything, right? If I take the square root of both sides, I haven't changed anything. It just comes back to 4 over 4. So it ends up being the same thing. So what this is saying is if I take this log of both sides, so I'll take the log over here. Log is an operation. It's a different type of operation than we usually have. It's kind of like sine or tan or cosine, like stuff from trigonometry. So it's similar to that. So I'm going to take this operation. I'm going to go log base b. Now we'll talk about this base b part, this little b here in the bottom here. So how these just happen to have to be the same. So I'm going to take the log of one side, and then just like I'm taking the square of both sides or taking the square root of both sides, I'm going to do the same to both sides here. So I'm going to take the log of this. Okay, I'm going to put extra brackets there. So you're taking the log of both sides. And because I took the log of an exponential is an inverse. It undoes the operation. So a log will undo this exponential. So if I input an x, I get an x out. This is my out. And this is my input. So that's what the whole point of this is, to kind of remove all these weird operations we have here. This base b, this could be anything, like down here it's a base 2. All right, so it removes that. So it kind of strips it away. So I input an x, I get an x out. But the problem is that on this side over here, we still have this log b y. So that's where this comes from, okay? So here's a little example here, right? So y is equal to 2 to the power of x. And you can change it around. I can undo this operation by taking the log of both sides. In this case, log base 2. Log base 2. And this is going to undo the operation, okay? So undo the operation here. This will pop an x out, and then I'm left with a log base 2 of y on the other side. Now the bases have to be the same. It's kind of like saying, like a log base 2 is different than log base b, unless b was 2, or log base 10, et cetera, et cetera. Okay. This is just saying the same thing. We'll talk about this later on here, but one thing that we're not allowed to take a log of are negative numbers. You can even just try it. Just plug in your calculator, and there's a log button on your calculator. Let me just pull my calculator out and show you. So right above the stow button here, there's an ln, and there's a log right above that. So right beside the 7, there's a log button there. Okay? So you just hit log, and then if I put a negative number in, I get an unreal answer. So it just doesn't work. Okay, so I'm not allowed to take logs of negative numbers. Technically, you're not allowed to take a log of 0 either. Now, it doesn't give you an unreal answer, but it does give you an error. All right, it's just domain error. Right? So I can't, that doesn't work. And a few other things, like a log of 1 will always be 0. Okay, we'll talk about that as one of the rules later on that we have. Yeah, so I can't have negative values of x's. That's fine. Yeah, so exactly what that says there. And the little note here just talks about what we just talked about here, how we can switch between these. Oops. All right, sorry about that. So yeah, so we could switch between these two pretty easily. If I look at this, I can look at what they have here. If I have exponential, y is equal to b to the power of x, I could solve for x. So I can rearrange this to get x by taking the inverse. So I can switch between these two. And then I've got to go vice versa too. If I have a log, I can go back to exponential. The key is that the reason they put the log here first is because logs were actually invented first, and then they used that to find exponentials later on. So it's a weird thing that we talk about exponentials and then we talk about logs, but logs were technically invented first, and then it was exponentials. Anyways, so we can use this knowledge that we could switch between exponentials to logs pretty easily. So here, all we have to do to do this is to identify a few things. This 4 is the base. We talked about that in exponentials as well. The 4 is the base. Obviously, the 3 is the exponent, and then you got your solution on this side. So what's going to happen is that these two are going to switch their spots. So I got a log. If I spell log properly. Okay. So I got a log base 4, so that stays on the same side there. You can see log base 4. This is a base 4 exponent. And then these are going to switch. I'm going to log base 4, 64, so that goes in that spot, is equal to 3, so they switch. So rather than being equal to 64, now it's equal to 3. Okay. So here we've got a log base 2. So I know this is going to be a base 2 exponent. So I know this is going to be a log base 2. So that's a little 2. It's like a subscript. Okay. And then these other two pieces, the negative included, are going to switch their spots. So this is going to be a log base 2 of 1 over 8 is equal to negative 3. Like I said, you can't take the log of a negative 3, but a log could equal a negative number later on. We talk about how do we get these in our calculator in a sec. Because you've got all these bases, but on your calculator, it's just a log, right? That's all it says. It just says a log there. My log almost had, oh, my buttons have mustaches now. But that's just a log. It's not like a log base 2 or log base 5. It's just a log. We'll talk about what that means. Do I have a note up here yet? No, my note's down later. Is it? Must be later. That's weird. I thought I had a note here talking about what a log base 10 looks like. Yeah, just 1 second. Oh, it's much later on. There's a little note later on. I have like a page. It's in the next lesson. Well, I show it to you after a bunch of graphing here, where we talk about the log on your calculator, the log without any base, it just says log on it. It's technically a log base 10. It's what we call a common log. So usually, if you don't see, well, not usually, if you don't see the 10 or you don't see a number there, it just says log, we assume it to be a log base 10. Okay, that's going to be useful for the next question. And then later on, we're going to talk about this natural logarithm, where we have what we call a base e, which is a special number like pi. It's like pi. It's not exactly pi. It's like 2 point something, when pi is like 1.3 or 3.14, sorry. So when we use log base e, rather than writing log base e, we write down ln. It's used a lot in economics, nature. That's why it's called the natural log and stuff. It's very related to like the what do you call that? The golden ratio and stuff. Anyway, so here we got a log base 10. Okay, so this is going to be log, and it has a 10 there. So this is the base here, right? So the log base 10. These two things are going to switch aside. So it's log base 10 of 100 is equal to 2. So rather than writing log base 10, because it is base 10, I don't have to write it. So I could say log 100. And I could just punch in my calculator now. We go log 100. I go log 100. I get 2 out. Okay. So this is, yeah, so we already kind of knew that as well. 10 to the power of 2 is equal to 100. Okay. Oh, let me just get rid of this on the side here. It's in my way. Okay. So you can do that with everything. So here, it's a base x here. We don't have a number. We can just put whatever we want there. So this is going to be a base x. Well, we won't put whatever we want, but it could be whatever number we want. These are going to switch aside. So I get a 5. And then this part of the exponent is going to drop down, switch with that guy. The whole exponent, like I said before, with the negative goes with it. So that whole thing goes to the other side. So this one's going to be equal to d. It's going to be a log base x again. I'm going to put an f in there. Now you don't have to put the brackets around that. You can go log base x f. As long as you don't make those two things the same size, won't get confused. Okay. Here, this is the most common reason why we do this, because I want to figure out, okay, what x value would I have to put there to make this equal to 125? So rather than guessing or changing bases and stuff, I can change this into log form. So this would be a log base 1/5. So that's going to be a tiny little 1/5 there. We put brackets here. 125. So those are going to switch their spots. Is equal to x. Now, I can punch this into my calculator and now solve for x. Okay, but we're not going to do that yet. We haven't got to the point where we're actually punching these in my calculator. Okay. Yeah, so we'll keep on going here. I can always go backwards now, where you can follow this little 7 rule, the rule of 7, where if I want to go from a log back to an exponent, I kind of draw a little 7. So I go from the 7 here, go to there, and then that way. So what's that saying is 7 to the power of 4 is equal to x. So when you see a log like this, it's just saying what to the power of 7 is equal to x. What to the power of 7? So when I look at something like down here, b to the power of something has to equal this 6 here. Anyway, so you can draw that little 7. Now remember what I said before. If you don't see a number, you assume it to be 10. So this would be 10 to the power of 3 is equal to 1,000. Which kind of makes sense. 10 to the power of something has to be 1,000, 10 to the power of 3. You put it in a calculator, 10 times 10 times 10 equals 3. Or 10 times 10 times 10 is equal to 1,000. Now, an ln, didn't talk about this one before. I don't have it up here. I probably should put that note a little bit earlier in my notes here. But an ln is a natural log, right? So this is the same as saying log base e b is equal to m. So I'm going to draw my little 7 based on this e. So it's going to be e to the m is equal to b. So you're switching these as well, just like we did before. You're switching these two things. So rather than being equal to 3, it's equal to 1,000 now. Rather than being equal to 4, it's now equal to x. So you're just switching those two. And you're switching the whole side. So this whole side gets switched over into that side. So rather than being equal to b to the d, now this is going to be equal to a. And this is going to be 1/2, that's my base, to the power of, I'm doing a little 7 here, b to the power of d. So there's a lot of exponents there. Okay, that's fine. Now, one thing about this is a very special thing about this rule. This rule changing between them, you notice that up here, there's no number in front. So there's a 1 in front, there's a 1 in front, right? So that's important. There has to be a 1 in the front. So I need to get rid of this 4. So what I'm going to do first is divide by 4 on both sides and say log base b is equal to 5 over 4. I just give it that extra both sides there. Now I can do our little 7. So it's b, my base is b. Raise it to the power of 5 over 4, and that's equal to 6. And now I can solve for b. If I wanted to solve for b, I can figure out what my base is. But I don't want to in this case. I don't care. Okay. I just wanted to change it into a different form. Okay. So this last page here, what I'm going to do is I'm just going to stop this video and then come back to the next video, part 2 of this. And we'll go over these. But I want you to try them out first. The last one here is actually solving them. So you actually want to figure out what y value, what x value would I need to get this to work. Okay, I'll see you in the next video. Bye.